the noise you want to add on to your data set. Okay, the noise. It's up to you, okay? Up to you. Sometimes you can adjust the number by yourself and then you can see what happened if you change the numbers. In the function, we can get the output x and y, okay? Two columns. Okay, two columns, you can get x and y. And then, this is the new function about the standard scalar. Actually, it is the useful pre-processing function, because in the machine learning, you know, when sometimes when you correct the data, you correct in the various of unit. You know, for example, you correct the information of the human, like the weight in unit of centimeter. The weight is in unit of the kilogram, and the height, the unit is centimeters, right? And the age in the unit of the years. Yeah, and you correct the data from blood pressure. Okay, maybe the blood pressure, it is another unit, right? And you get the many information from the human. You get the various unit. Okay. What happens sometimes when you get the various unit, different unit, and you correct in the Excel file? Okay. If it's different unit, and you prove that, and you take that data to the machine learning directly, maybe the machine learning is going to learn the model very hard, or the output is will be not good. Okay, so we should do something before going to train the model. The things that we can do, we call the standard scalar or the normalization, because this process we will try to make the various unit become the same length, okay, the same length or the top length with the some mathematics. We call it, okay, if you want to know, the background of this one is come from the, we call standardized. Okay, yes. It comes from the statistics. X is data point, right? Data point from your table. U is come from the mean, average. Okay, and divided by S is standard deviation. Okay, so this is the equation, the background mathematics from the standard scalar. Okay, it tries to transform your data with the different length to be the standard length, okay, before training the model. Okay, so this is the meaning of this coding. Okay. Yeah, I also give you the information why we have to use this one. Okay, before in the basically that I told you, it is the prevent the feature dominance, and also it can be improved the algorithm performance. Okay, if you do the standard scalar before training the model. After that, okay, you can plot the graph. because right now x is, if you want to see what the x, yes, x, this is the x parameter. X parameter is correct in the two columns. Two columns, right? It looks like this is array of the two columns. And in my case, I have the 750 lines, number and two columns. And then we try to plot scatter here. What is the meaning of this one? The meaning of this one is mean you want to get the first column of the x parameter because the first column, this is first column, the index is 0, okay? And this is the second column. Second column, the index is 1, okay? So that's why we use this one. Like you want to get the first column, it means index 0 and index 1 for the second column. And then you plot it by scatter. Okay.
Could
Okay. So this is just the generate the data point and data visualization. Okay. And step 2, you can apply the k-mean clustering as the last week, at the last time of the class. Okay. Apply k-mean by k equal to, okay, because you know it looks like should be separate two groups, right? Okay. In your sense, in your human sense, you can say that the two groups is suitable. So the k-mean, you can define the n cluster as number 2, right? N cluster equal to dot if x. Okay. Easy, right? From the last time you have done the k-mean like this, and you know when you training the data from the k-mean, the output of the k-mean, you can know the centroid in the final. Like what is the position of the centroid? Two centroids. In this case, we have k equal to, it means we have two centroids. Okay, this is centroid 1, this is the centroid 2. Okay, centroid 1, centroid 2. Okay, we have coordinate points of centroid 1 and 2. Okay, after that, data visualize again. Yes. Data visualize. So you can see we have two groups. Yeah. And this is the centroid 1 and centroid 2. But as you can see, it doesn't make sense with the human eyes. Okay? With k-mean, it doesn't work in some cases like this. Okay? So we try to use the DBscan technique. Okay? In the next part, apply the DBscan. Okay? The DBscan you can import the function DBscan here, from the sklearn dot cluster. We can import the DBscan, and we have to define how much or how many epsilon and how many minimum sample or minimum point, as you learned in my explanation before. Like, we have two parameters, we have to adjust. Actually, we don't know how much. We don't know how much is suitable. But okay, in this case, I give you the suitable parameter for you. Okay, but maybe the homework I will talk later. As the last time when you do the k-mean clustering, right? We have to use the method of the elbow plot to check how many k is suitable. In this case, also in the homework, maybe you have to study by yourself about how can we find the suitable of epsilon and minimum point, because actually we don't know these two ones. Right? If you assign the wrong orders, unsuitable, you can get the unsuitable answer also. But right now, okay, let's set the number here, and you can see the output later. But it's up to you. Sometimes, okay, you can play with the number. Sometimes you want to change it, you can change it, and you can see the output and compare to your friends again. Okay, random. Okay, you can random it. Okay, but this one is the suitable one. So in the DBscan function, okay, you just insert the data epsilon and minimum sample here. Okay, just two parameter in the function. Okay, and then you use the .fit predict to train the models, and then okay, the next part. This part I try to check. This is my additional code for checking, like after you training with the DBscan finish here, okay, with epsilon and minimum point, this number. We want to check how many group as the output and how many noise still is on your data set. Okay, so in this part it gives the answer. And if you run this block of your coding, maybe it's different computer by computer, because it comes from the different random number at the first step. Okay, in my case, if I set the parameter 0.3 for the epsilon and 10 for the minimum point, I will cluster the group into two groups, and the estimate number of noise we have 2 points. So it means after we cluster the group, we still have the noise, 2 noises. Yeah. So you can do the data visualization in this block. Okay, but okay, I declare you already this one. Nothing to fill the information anymore because it's so long. But if you have some question, you can ask again. Okay, so this is the output. As you can see, we have 2 different groups and 2 noise like this. Yeah, but what happened? Because someone changed this one, I think. Okay, for example, if you change like epsilon, like 0.1. Okay, 0.1 and min sample is 15. Changing a little bit. Oh, 0 group. So 0 group. So if you change the number with the unsuitable, you might get the unsuitable, right? 0 group. And the noise is 750 is the noise, the zero group, right? It doesn't make sense, and we change like 0.6, okay, and 10, what happened? One group. So it looks like the whole data is the same group, right? So your homework, okay, because this data is easy when you look by your eye, okay, to group, right? But let's imagine that your previous homework if you have the data like your homework last time, we don't know how can we adjust the epsilon and minimum point, right? Okay, it's not the same. The easy example here. Okay. So the first homework, I want you to study yourself about how we can tune the parameter epsilon and minimum point in the DBscan, and I give you the keyword silhouette. Okay, you can search the silhouette. It gives the keyword, okay, and a lot of examples in the internet. Yeah, you can study yourself and follow some coding example and apply to the homework. Yeah. The silhouette is gonna show you some output, and you plot, and you can notice the graph, and then you can know which point on the graph. It looks like the elbow plot. You know, when you plot the elbow plot, you can know, okay, maybe this point is look good. It look good enough. Okay, the silhouette it look like that. Okay, but you have to study yourself. And submit it in the, okay, I want you to submit in the PDF file, okay, because I can open it easily. Because if you apply me in the Jupyter notebook file, difficult to open and check it in my iPad. Okay, so please convert the. Do you know how to convert the Jupyter notebook to PDF?
Oh, okay.
Maybe, okay, just right click print, okay, like print, yeah, and change it, save in PDF file, yeah. It's gonna save everything in the PDF file, yeah. Okay, please convert the file to the PDF before submit your homework. Okay. And extra, extra is up to you. Okay, if you want to apply the silhouette and the DBscan technique with the weight and height Excel file the last time of your homework, you can apply. Okay, but if you don't want, okay, you can apply the silhouette technique with this data point you have. It's up to you. Okay, if someone want to learn more, okay, about the silhouette with the real data you have from weight and height, correct from your classmates. Okay, this is the first one. Any questions? Do you want to take a break? 10 minutes? 10 minute break. And after the break, we will learn about the another technique we call the fuzzy seaming technique.